Hello and welcome to Knowledge Review number 4. In this Knowledge Review, it is time for us to test the skills that you should have picked up from the Language Fundamentals 2 section. We've covered a lot of different things that were related to variables. As a matter of fact, there were a little bit over 4 hours of lecture that was presented. Now what we need to do is find out if any of that lecture sunk in. Now we've got 2 different challenges that we're going to be presenting in this Knowledge Review. Both of them are just a bit more challenging than knowledge reviews in the past volume of the XNA Xtreme class. Don't panic if you're still relatively new to programming and you hear one of these challenges and you think, how in the heck would I go about solving that? Here's how you're going to do it. Start with paper. Don't just jump into Visual Studio and start typing stuff out. Use just a regular piece of notebook paper, a pen, and start drawing out the flow of logic first. Once you have a solid plan in place, then go over to Visual Studio and start constructing your application. So with that, again, there's 2 challenges. Let's go ahead and start out with the first one. Listen very carefully. As a matter of fact, you might even need to rewind and listen to it again if need be. Create a program that asks the user for their age. Make sure to verify the number that they enter. If it is not a valid number, tell them that they, quote, don't grasp the concept of numerical input and have the program terminate. If the number entered is valid, make sure that you store it in a variable. Next, ask the user what age do they fear the most. Once again, make sure to verify their entered number. You want to make sure that it is, again, a true number, that they haven't typed in something like cats. Again, if the number is invalid that they entered, repeat the comment given above, where you're going to tell them that they don't grasp the concept of numerical input and have the program terminate. Now, if that number is valid, make sure that it is being stored in a variable. Now that you have 2 valid variables at this point in program execution, compare the difference between the 2. If you find that they have yet to reach that age, the age that they fear, tell them that they have X number of years until the day they fear arrives. If you find that they are older than the age that they fear, tell them that they have survived X number of years since the day they feared. Now, there are many different ways that you can approach this problem. If the way you come up with is different than ours, which I can almost guarantee you that will be the case, no big deal. If in the end it functions and it functions properly, you have accomplished this mission. The idea is to watch how we do it, and that might perhaps give you some tips or some ideas of another approach. Now again, we are staying within the scope of everything that we've presented in Volume 1 and Volume 2 of the XNA Xtreme course up to this point. Now there are different ways that we would handle this assignment if some of the future lectures would have already been presented. Since those lectures have yet to be presented, we've got to stay within the confines of what we have already taught you. So keep that in mind. Alright, with that, let's go in here and turn off Group 2. And you may pause now. Now, just in case you haven't paused, remember, you don't cheat. There's no reason to watch us. Give this a shot. Try it for real. Okay? And then if you get stuck, no big deal. Watch and see how we did it. All right, so pausing, and unpausing now. Welcome back. All right. Well, hopefully you have successfully completed the assignment. And if not, no big deal. I was going to bring up a whiteboard here, Logan, but there really is no reason because let's just jump right on over into Visual Studio and create this.
Okay, let's begin a console application. And inside of this console application, let's begin on the task at hand. As a matter of fact, let me think about how I want to approach this problem first.
Sure.
Since we're going to be dealing with input, and there's going to be the possibility of getting bad input such that we stop the program, I'm going to put all of the input processing in its own method.
Okay.
And have that method set up so that it returns true or false depending on if it got good input.
Sounds
so that way the moment we see that it gets bad input, we can immediately stop.
Okay.
So before I even get into coding main, I'm going to jump down and begin on that method. I'm going to make a process input method. It's going to be static since we'll be calling it from the main method. It's going to be have a Boolean return type because I want to see if it worked or not. And it is going to be called process input. And we don't need to take any parameters, so we'll block this in. Alright, now the first thing we want to do is ask the user how old they are. So we're going to, of course, need to do a read line to get the information, but before we do that, we need to do a write line so that they see the question to begin with.
Precisely.
So we'll do a console.writeLine, and I will write out, would you want to say, what is your age or how old are you? Or
yeah, something along those lines. As a matter of fact, let me see this over here. I can help you out.
So I've got, how old are you? Alright, now we need to read that input in.
Okay.
So we need to jump down, and we of course need a read line, but we need to store the input that we get back in something. And I'm going to call this, since we're asking for the age, I'm going to make a variable called age input. Okay. That's going to be a type string. So that way, because of course we need to do some checking, but before we can check, we need to have something that can store the input.
Right.
And we're going to use a string in case they typed in letters and not just a number. So we'll have a string called age input, and that will be equal to console.readLine. So readLine will run once the user hits enter, then whatever they entered gets stored in age input. Now, I want to check this and see if this is a valid numerical age number. So I'm going to have a variable for storing an age, and then I'm going to try to put the contents of age input into that variable. So I'm going to start by defining age. As a matter of fact, since we're going to be dealing with two ages later when we get into the rest of the program, we're going to have the age we fear, whereas this is the age we are now. So I'm going to call this current age. So I'll have a current age variable. Now let's try to populate that with the age input information. So let's do this inside of a check. So we'll say that if not int.tryParse, where we will try to parse in the age input data and try to put that out into current age. Of course, I'm doing a check with not so that we can tell, because if this works, that means that we'll have current age populated with the inputted age, and we want to continue on. The only case I'm checking for is if that fails. So if tryParse returns false, then handle this here. And the way we'll handle this is by simply returning false. So that way we can indicate through process input that the processing of input failed. But if it succeeded, now we should have current age stored in the current age integer variable. Now we need to get the age that they fear. And this is going to be the same type process. As a matter of fact, before I go any farther, let me make sure that I haven't introduced any simple errors yet. And I'm going to ignore this one for now. Well, I don't have to ignore it. I could jump down here
and just simply put a return true.
Because what this means is if we get through all of our input, we're going to return that input was successfully handled. All right. Now back to...
Now go ahead and build real quick just to show them that the error goes away. All right.
Now we want to ask for what age they fear. So I'm going to take this same code, copy it, and paste it in below, because it's all the same thing, just changing the text and the variables that we store the information in. And this is going to be something like...
What age do you fear?
What age do you fear? And this is going to be, I can call this fear input. And maybe age fear input would make more sense, but since this is used in such a close sense, we turn right around and use it here. I'm not going to worry about that. We'll just call it fear input. Though, of course, I do need to remember to put that into our tryParse. Now, current age, this is no longer current age. This is the feared age. So the feared age, of course, this is where we want to store the input if it works. If it doesn't work, again, we just return false.
Okay.
And let me do a quick build.
Now, we could go ahead and jump back up to main, finish that off, so that we could simply show them that they haven't entered in, they don't grasp the concept of entering in a numerical number, and then run it and type in like CAD or something like that.
Right, since process input should now work. While it doesn't do anything with the current and feared age,
it is verifying that the numbers are truly numbers, because if they're not numbers, we're going to get a return of false.
Okay. So let's jump up to main for a minute, and let's do or code in this check. As a matter of fact, we'll do the check and running of process input at the same time. So the way I'll do this is, instead of an if statement, I'll say if not process input, then that means process input came back and told us we had invalid input. So
right.
This is where we can do our write line for that you don't grasp the concept of text input. So we can do a write line and say you don't seem to grasp the concept of numerical input. Then end that off, end off the write line. And after that, we want to always hold up before we exit out, so we can do a console read line. And even before that, since this has been an interactive program thus far, I also want to put out a line saying or indicating that they need to hit a key to dump out.
Okay.
So the console dot write line. I'm going to put a new line character before this as well, so
just
that
to push
it's
it
spaced
down.
down.
Yeah.
So we'll say press enter since we're doing a read line. So press enter to continue. All right.
Now, before Logan actually runs this, all right, you just built it, so everything builds fine. I do want to point this out, though. Again, for those of you out there that are still relatively new to the whole programming concept, the logic right here might be just a bit fuzzy to you. What is happening is Logan's actually doing a couple of things on this one line. He is making a call first to the method process input, which is going to return a bool value. So we come down here and it rather returns a true or a false. Now let's think about it. If they typed in a bad age or a bad feared age, then what happens? We get a false return. If we get a false return back in here, that means that they've typed in something bad. We're using the not logical operator right here. This is basically going to toggle what we get back. So if we received a false back, well, if it's not false, it must be true. That means we can enter into this portion of the if statement, because this, of course, executes if this was found to be true, right? So again, if process input comes back as false, it gets toggled with the not, which makes it true, so then we end up in here. If process input successfully processed the input and a true got returned, this would be replaced with a true. It would be toggled to a false, making us skip over and come down here, which will just simply say, at this time, press enter to continue, and that's the end of it. Okay? So I just wanted to kind of walk you through the logic real quick.
If you don't mind, there's another way I could restructure that to show another way you could do that without the not, but then explain why I used it.
No, both ways is great. The more we show, the better.
Because, for example, let's say that
we could break it out into multiple lines. You can go ahead and create a bool above.
Even better, this is what I was going to try to show.
Okay.
Saying that, like, for example, let's not negate this. So let's just check to see if process input was true. And if it was true, let me just comment in here. And then if so if it was true, we would get into this block of code. If it was false, we could catch the false with an else, so that inside of the else we would have false. Now where would we want this to go? Well, we'd want this to go along with the false return.
Right.
So we'd have something like this. But because we didn't want the program to do anything when process input returned true, there's no reason to have this block. This is an entirely wasted block. All we're interested in is the false output.
Gotcha.
So that's why we use the not operator to toggle that over, because that's all we're interested in, is the false only. So with that, I can have only one line inside of the if, and I don't need an else clause.
There you go. Very nice. All right, so let's go ahead and run this and test it out. So right away, if you type in something like 55 and hit enter, it's just going to say, all right, and then let's type another valid number in. So what age do you fear? 100. And then press enter to continue. So if he hits enter, of course, that's the end of the application. Let's run it again. All right, so now if he types in cats or something, that's not a valid number. So if he hits enter, you don't seem to grasp the concept of numerical input. Press enter to continue. So go ahead and hit enter, and that's the end of the application. And same thing applies if he runs it one more time to check the other scenario. He enters a valid number here, but then types in cats and hits enter. Again, you don't seem to grasp the concept of numerical input, and it dumps out. And that's it. Okay, so very good. We now have the checking in place. Now we need to just go ahead and do the final thing, which was tell them they have so many years until that day gets here, or they have survived so many years since they are older than the age that they feared.
Okay. So let's jump down to just after we've gotten all of the numerical input, and let's do some checks on that input. Let's first check to see if age comes before the age that they fear. So we'll begin if and say if current age is less than feared age, then we want to say something along the lines of console write line, where we write out, you've got, and then we'll put in a space, end the quote so I can concatenate onto that, our feared age minus our current age, because if that's the case, then current age, or feared age is larger than current age. Then we'll add on, or concatenate onto that. You've got that many years. Did I type that right? No, I missed an R. So you've got that many years till the day you fear. And we can end off the right line.
Now, for instance, if, let's say, you are 39 years old and you fear the age 40, so current age will be less than feared age, and then we come down here, and 40 minus 39 would be 1. You've got 1 years. I guess we could put that in parentheses if we wanted to get real fancy. So you've got 1 year till the day you fear. Okay? So very good. So now we can go ahead and jump down and do our else if.
So if that case wasn't true, let's check and see if it's the other way around. If the current age comes after the feared age. So we could do an else if, and then this time is the check if current age is greater than feared age. Then what do we want to do? Well, to begin with, I'm going to get lazy and snag this line, copy it down here, just so I don't have to retype the whole line. Now, what do we need to change? Well, since you're not looking forward to something, instead this is a time past, we'll say that you've survived. So you've survived how many years? Now we need to swap the order of these, because current age, in this case, is larger than feared age. So we don't want to come up with a negative number. So we'll do current age minus feared age. So we've got, so you're saying you've survived so many years since the day you fear. All right?
Very nice. Now here's the bonus part. Dun, dun, dun. That's right, there's a bonus. We did not in the spec say what happens if you happen to be the age you fear. So if you were thinking and you caught that, outstanding. And if you didn't, that's okay. It wasn't in the spec, but let's code it in.
Okay. So what to do if current age is not less than and not greater than. In this case, I'm not even going to run another check, because with these being integral types, that means if it's not less than and not greater than, the only other thing it could be would be equal to. So I'll just do this inside of an else. So otherwise, the ages are the same, or we could write out something like, whatever we want. So if this is the age that they fear, we'll just say, like, be afraid. Like so.
Very nice. And that takes care of the application. Let's go ahead and run it and test it out. Let's see. Age, I'm afraid of 50 for whatever reason.
Or how old?
Oh, how old are you? Tell you, that's what happens when I'm not looking at the screen.
I can't write into the future.
All right, let's see. How old am I? 37. And what age do you fear? Let's just say 50. And we hit enter. Wow, I've still got 13 more years till that day gets here. Oh, okie dokie.
Very nice.
All right, so let's go ahead and try out a couple more scenarios. Let's say that I am 37, and I feared turning 21. And then enter, and I've survived 16 years so far. All right, very nice. All right, let's go ahead and hit enter.
I guess fear should be in past tense, since the day you feared.
Oh, yeah, good point.
Unless you still fear it, but I don't know why you'd fear something in the past.
I still fear it, so we'll leave it. All right, so let's run it one more time. And let's say I'm 37, and for whatever reason, I really feared 37. And be afraid. Outstanding. That was the application that we were looking for. Again, there were different ways that we could have gone about doing this, right, Logan?
Right. I mean, we could have, if we wanted to, we could have probably found a way to avoid writing another method. We could have, well, if we had other concepts that we haven't covered yet, there's things we could do, but I mean, that's outside of the case.
So there's a lot of different approaches. So if you came up with something that functioned the same way with what we are showing you here, excellent job. If not, or if you just ended up getting completely confused, study what Logan has coded here. go back, listen to the problem as we presented it, and see how the original word problem translated over into this code. Okay? Now, that is going to wrap up this one, so Logan, go ahead and discard that.
All right, I'll just do a closed solution.
Okay. And I'm going to jump back over here to the whiteboard, and we will turn this off, and knowledge review number 4. Welcome back. Here we are with our second challenge of the day. So listen very carefully. Think back to the enumeration video, which was the last video, so you don't have to think far. In that video, we discussed writing a mock-up software for a remote control. And I had even given a hint in the video that we were going to do something with that in the knowledge review section. Now, I'm going to give you some code here. So let me go ahead and jump over here, pull up a whiteboard. Your main method will contain only the following code. Transmit 77. Now, you're going to do a console.readline just to hold up execution after anything gets written out to our console, and that's it. So this is your code for your main method. Okay? Now, another thing that you're going to need to know, our IR codes. We're just going to stipulate that you've got play is 53, you've got stop, which is 16, you've got rewind, which is going to be 12, and then you're going to have fast forward. Which will be 13. Alright, so obviously we're dealing with enumerations here, and a few other things as well. But here's the kicker. Let me go ahead and go back over here to my challenge. Remember when we were creating this originally, we said that some other company handled creating the circuitry and the logic for accepting a user pressing buttons and handing our software just a raw code. All right? Well, here you go. This is our raw data. Now, just looking at 77, we can see that it doesn't exist down here, right? But that's irrelevant because the software's got to actually check that. So let me read out the rest of this now. Have the transmit method. Obviously, you guys have noticed that you are calling a method, so you better create a method called transmit. There's a nice clue for you. Have the transmit method cast the raw data into an IR code. Before using this code, you need to verify that it is valid. Call a method called isValidateCode and send it this newly assigned IR code for verification. If the code is found to be valid, write out, and we're going to write out basically the same thing we did in the video where we went over enumerations. Do something along the lines of transmission action. Let's pretend that it received a 53. What should happen would be transmission action is play. And then it should say transmitting IR code 53. Again, we are stipulating here that this 77 over here, if we send it 53, that's what should be output because 53 has been validated as a good number.
55?
Okay. 55? Huh? Oh, why did I write 55? Whoa, thank you for catching that. Brains all over the place. 53. Thank you very much, Logan. Now you guys know why we have 2 people on all videos. Because sooner or later, one person's going to screw up. Okay, so if, on the other hand, the code has been verified as bad, then what should happen is you should get a message on the console that reads something along the lines of transmission aborted. Unknown IR code, and then give them the IR code. So unknown IR code, well, we can go ahead and use our example from above because we know that's going to be bad. Unknown IR code 77. Okay, so that's what you should get if you have a code you cannot verify. That is what we're looking for. Logan, is this pretty clear?
Oh, yeah. Sure.
Okay, so that's the idea. Again, this is the only code right here that you can have in your main method. You're going to need to write two methods. You're going to have one that's called transmit that's going to need to receive in raw data. So you got to think about data types here. And then you're going to need one that is called isValidateCode, or you could call it isValidCode, whatever. And inside that method, that's where you're going to need to check to see if it is a valid IR code. So with that, again, pull out a piece of paper. Start planning. Think about it. I'm going to go ahead and come on back down here and tell you guys, woohoo, to pause now. So hopefully they're pausing, Logan. I'll go ahead and turn that off for the second. And welcome back. All right, so you should have paused. Hopefully you were able to knock this one out in a few minutes. This one is not a super challenging one. The last one probably required a little bit more thought than this one because we gave you a good bit of this over in the enumerations video. But Logan, let's go ahead and jump into Visual Studio and put it together real quick.
Okay. So let's begin with the project, which will be a console application. Now, the way I'm going to handle this is I'm going to begin by filling in all of the things we know, because we saw what code we're going to have in the main method, and we were pretty much given all of the things that we need in our enumeration. So I'm going to start with main. I'm going to put in the two things that we know we'll have. We'll have a transmit, or a call to transmit, where we try to transmit the data 77. And then we're going to do a simple console read line just so we can see whatever the output of transmit was. So we know we've got that. Now we also know that we're going to need our enumeration. So I'm going to jump up above the class program and define our enum. This enum is going to be called IR code, because like we had hinted before, this is going to be very much like the remote code given in the previous video. So I'm going to name it the same, IR code. And in the whiteboard we had a second ago, we know that we're going to have play, stop, rewind, and fast forward, where play is equal to a value of 53, stop is equal to a value of 16. Let's see what we got. Rewind is equal to a value of 12.
And fast forward is 13.
And finally, fast forward, fast format.
That's awesome.
Is equal to 13.
Okay.
And let's see. Now, after this, of course, we need to have a transmit method to handle this data. So I'm going to jump back into the class program, jump below the main method, and we'll code in transmit. It's going to need to be static because we're calling it from main. It can be void since we're not checking the return value. And it is, of course, called transmit. Now, for transmit, we need to take in whatever code is being fed to us.
Now, that code is not an enumeration code.
Right, this is just some numbers.
That's right, it's just a number.
We need to take in numbers on this side. Since we hadn't specified any real range, I'm just going to do an integer so we have a significant number of, or amount of data that we can take in both positive and negative.
Around 65,000 of them.
So we'll define this as an integer, and we'll call this parameter raw code. So that will be the skeleton for our transmit method.
Okay.
Now let's see what we need to do with that. The first thing I want to do is to cast this raw data over to an actual IR code, or an actual variable of IR code data type. So I'm going to define that variable as an IR code variable called code, and we'll go ahead and initialize that to the data passed in. So again, I'm going to need to cast, so we'll do parenthesis IR code for whatever the raw code was. So now we should have an IR code that represents whatever the passed-in raw code was.
Okay.
Now we need to do a check to see if this code was valid. Since we know roughly what we need to do here again, we need to know where we can know that if it's valid, we'll just do the same, show that we're transmitting, and if it's invalid, we know that we're going to show some another message. So I'll code that in before I actually get to the validator itself. So we'll do an if, so we can check. Now I need to check this code and see if it's valid. I haven't written the method yet, but I've decided that I'm going to call the method isValidCode. So we'll do a call to isValidCode, passing it code. And if it is indeed valid, this is where we need to show the transmission method. Otherwise, we need to show the fail method, that it's transmission aborted. So first, the write lines for if it is in fact a valid code. This will be console write line, where we will write out, what's the first one, transmission action. So, transmission action. Then I'll concatenate onto that just code, because this will give us the text name of that identifier for this code. And the second one, I'll get lazy and copy the line, so I don't have to type as much, and this is where we're transmitting what code exactly. So transmitting IR code, and then we'll cast code over to an integer, so we get to see the numeric value held in code.
Okay.
Next, we need to code in for what message should we display if we had an invalid code. I'll steal one of our current write lines, so we can put in something like transmission aborted. So let's say transmission aborted, unknown IR code, and then give the code.
Yep.
Alright, so let me do, well, if I do a build, that's going to come back as that, but we didn't get any other build errors, so everything else is looking good. Now we just need some method that can tell if an IR code is valid or not. So this is really going to be the heart of this whole example. Now I'm going to write out the isValidCode method. This is going to be static. It is going to return a boolean, because we want to be able to tell if it's a valid code or not. And the name of this is isValidCode, just like we were calling it before. Now we need to take in an IR code. And we'll just call that code and block in our method. Now inside of here we need to do some way of doing a check to say, is this any of the known IR code? So we need to have some type of check that says, is this play, or is this stop, or is this rewind, or is this fast forward? If any of those cases are true, then we have a valid code and we want to return true. And otherwise, if it wasn't found to be any of the known cases, we want to return false. And then I actually just said the key to this whole thing, which cases are we looking for?
Right.
We could do this entire thing as a switch, because then we could very quickly write out all of the cases. So I'll begin a switch. Switch, and we're going to do a switch on code. And I'll block in the switch. Now what cases are we looking for true? All of the ones we know about, all of the ones we've defined. So that means we're looking for case ircode.play. That's a valid one. And now, because of the nature of a switch, I can define several things that we're looking for, instead of just one and then continuing.
Yeah, we'll just utilize fall through here.
That's what I was looking for, fall through. So we could check for play. Otherwise, we could fall through to stop. Otherwise, we could look for rewind. Otherwise, we could look for fast forward. And if any of these cases are true, then we want to return true. Now, if none of these cases were caught, then we'll use a default, in which case we will return false. And that...
colon.
Good catch. Alright, so that, if I do a build, everything should now be good.
Okay.
And we should be able to test. Again, we've got our original code, so we're checking for, is 77 a valid IR code, and can we transmit it? So, let's run. Transmission aborted, unknown IR code 77.
Very nice.
And that was the expected result. Now we could go in and change this to something known, like we could change it to 53 and see if this is recognized as play. Alright, and it is. Recognized as play, we're transmitting IR code 53.
Alright, just for the heck of it, do 16.
All right, let's try 16, which is stop.
Very good. So it is indeed working beautifully. This is really an important concept to make sure you grasp when dealing with enumerations that have assigned values. And for whatever reason, now of course enumerations always have assigned values. If you don't throw numbers in there by default, as we said in the lecture, it starts at 0 and then 1, then 2, then 3, and so on and so forth. But if you need to go in there and specify specific values, and let's say that you're designing an application or a module for an application, and someone else is designing a module, and for whatever reason they're handing you information, and then you're going to use that information and represent it with an enumeration, you're going to need to verify that the number or the information they gave you is valid. Okay, so this is just, again, a mock-up example, but it is very important to understand the concept of verifying that you do indeed have valid information that can be accurately represented with the enumeration that you've defined, because if you don't, they can send in a bad number and it won't break anything in regards to how the compiler compiles everything. But your logic inside the application, your code, could end up breaking later on because it's not going to be a recognized enumeration. Okay? So that's pretty much all I wanted to give out of this example. Logan, is there anything else you want to add into this?
No, I think that pretty much covers it.
Okay, so again, the key thing was coming in here and creating the transmit and creating the isValid code, and in that, it really was all about taking in an integer and casting that integer over into a variable of IR code type. And this type, again, we defined it with a type definition up here above class. So since it's been defined, the compiler recognizes that this is cool. It's a new data type that we've put together, basically. And then we're going to simply send that IR code down here into isValid code. And then from inside here, we're going to simply use a switch to walk through and look at, is it play, stop, rewind, fast forward? If so, return good. Otherwise, it's not good. And that is being used inside the if statement right here. So whether we're going to get a true back or a false back. If we get a true, we do this part. Everything's good. If we get a false, we do this part. Okay? So that's going to conclude this knowledge review. Now, I know these assignments were just a little bit more tricky. I understand that. Don't let it freak you out. No panicking allowed. The idea is for us to work into a world of being able to put together applications with complex logic. And we have to slowly work our way there. We can't stay super simple forever. We've got to get you to start thinking logically. So that's the idea outside of just checking to make sure that you understood the concepts we presented in this section. So with that, that is going to wrap up Language Fundamentals 2, and it is time for us to now move on to Flow Control 2. Thanks a lot, guys.